Hello everyone. I'm Nicolas Orellana, a Chilean architect. So today I will present my research that I did at UCL as a part of my master course. My tutor was Kinda Al-Sayed, and the study is on spatial wayfinding, how the agents and human navigator patterns in virtual and real environments. So first of all, I will present the definition of spatial wayfindings, which is the act of finding a way, processing the input obtained by the spatial properties of the environment based only on visual cognition. So this process is composed by two acts, the act of movement and the act of pause and evaluation of the decision making. So, taking that into consideration, I started thinking some research questions, as for example, what is the role of the spatial configuration and what is the role of the three-dimensional properties of the space? How do the people navigate, where people pause, and what are the properties of those spaces? And finally, what do people remember of the space? So in order to answer those questions, I did that structure, which started analyzing the spatial properties of a case of study. Then I carry out some observation, virtual analysis, agent analysis, and finally analyze some mental representation of participants. So the case of study is Paris-Charles de Gaulle, Terminal 1 in France. I choose that airport because in an airport most of the users are first-time visitors. So they have to perform some wayfinding tasks in a very short period of time. Well, this airport, I analyzed the landside area of that airport, which is the weakest programmed area. In an airport, after you go through the security control, everything is so controlled, so I study the most weakest, where people can move freely, which is the landside area of the first floor. That is the diagram of the plan of that floor, which is composed by a main ring, a peripheral ring, a central ring, and 4 connections to that area. And then the security control is in the center of the building. So, well, here I'm presenting 4 maps, which I think are the most representative, or the ones which give me more answer to my research, which are the integration H8, the visual control, in order to analyze how the people move or where the people move to. The visual clustering, which is like a mix between convex and axial analysis, and the VEA through vision, which have presented previously some similarities with the real movement of people. So how or where the people move through and the movement to. Well, those are some data in relation with those analyses. And for example, in True Vision, the highest levels of True Vision were presented in the main ring, whereas the least levels are in the peripheral space, which is that one. So then I moved to analyze how the people navigate through that building. So what I did was follow 15 people from the main entrance, which is that one, which is the entrance which connect the train station with the airport, and follow people during 10 minutes or until they change the activity from movement to pause or standing or sitting. So the first thing that I found was that when you are in a real environment, there are some elements or distractors which are making a little bit difficult that kind of analysis. Because people don't move just because of the property of the space, but they also talk with other people, ask, read, signs. So there are a number of elements which are in the space which highly influence the movement of people. And for that reason, most of the people found the way just in the first half of the building. But anyway, I was correlating that half of the building, this first half of the building, with the through vision analysis, and I found a high correlation of 70 R square 0.71, which means that there are a high correlation between that movement and the through vision analysis, but that's in half of the building. I can't analyze the whole building because people find a way before they move around all the building. So then I moved to another kind of analysis, which is the virtual analysis. What I did was recreate the plan of the building, or recreate the virtual environment in a simple space, which just contain spaces. No colors, no people, no sounds, just a space in a simple way. So the people can move through this space using some devices and projectors. And in that way, I can analyze how the people perform in an environment which is only composed purely by space. So then first of all, I correlate that findings or that movement, which are those paths, with the real movement, in order to see if it is possible to correlate that kind of experiment with the real navigation. And surprisingly, I found that there is a R square of 8.82. That means something like an 82% of correlation between the real and the virtual analysis. That validates the use of that kind of tools or technology in order to understand how the people move through the space. Also, I run an analysis or a correlation between that virtual navigation and the through vision, and I found that there is a 83% of correlation. That means there are more correlation in a virtual environment rather than in a real movement. So, how I found those high levels of correlation, I started moving and analyzing different kind of environments in order to understand how the three-dimensional properties of the space can influence the movement. So I create three spaces. The first space, that one, space 1, or space A, is composed just by walls and ceilings in a same height all around the building. So it's a basic space, it's an extrusion of the plan. The second space and the third space are created from the same plan configuration. But the second space, the space B, has a random ceiling all around the building from 5 meters to 20 meters in the highest point. So it presents a really different 3D dimensions all around. And the third environment is that one, which is exactly the same form of the space, and also include transparency in some walls. So then I trace the movement of those participants, 25 participants per environment, and saw how those movements are related with the real movement in the building. So I found interesting correlation between the space A and space B with the real movement, with an 65 and 62% of correlation. That made me think that probably the three-dimensional properties or forms of the space doesn't considerably affect the movement through the space. Whereas in the space C, where I include those walls with transparency glasses, they were a low correlation. So probably the inclusion of transparency in that experiment doesn't help me and probably work as a distractor in the movement or in the performance. Then I started looking where the people stop or where the people pause to take a new decision about the movement. So I found 11 clusters where the people pause for at least 5 seconds during the navigation. And I found those clusters where in a radius of 10 meters, there are at least 10 pauses points. So I started looking how those pauses points are related with the spatial configuration. And I found interesting correlation with the integration HH and the visual control. In fact, well, this is the integration and that is the visual control. And in fact, all the pauses were performed in the high quarter of the visual controls levels of the building. And that means all those pauses were in the highest or in the red areas of the visual control. Also, I was looking how those pauses are related with the isobit properties. So, again, I found some clear relation between the isobit properties or perimeters of those points and also the minimal radius. So the minimal radius always was 2 times the average minimal radius of the building. The perimeter was 3 times the average perimeter isobit properties of the building, and also the area. So then I was looking how or when the people pause during the navigation, and how many meters they walk before they stop. And it was a little bit more random findings. I mean that there is not a clear rule that make me think, well, the navigation and the pause has some relation with the time. But probably there is a more relation with the properties or the dimension of the space, not only the spatial or the integration, the connectivity, but also the dimension of each space, where the people tend to pause less in a bigger area. So then I moved to the agent analysis. Using DefMap software, I was running some analysis in order to understand how we can recreate the movement just using spatial properties. So I ran the agent analysis using some configuration we have been showing previously, high correlation with the human movement in urban areas. As for example, we can give a number of 3 parameters to each agent, as for example the field of view, which in this case is 170 degrees, and the number of steps they give or they walk before they re-evaluate the route, which in this case is 3 steps. 3 steps and 170 degrees, which have present previously high levels of correlation with urban performance of people. But in this case, the correlation wasn't too high. Well, it was high in the standard and the line of sight length analysis. But in the occlusion group and in the further occlusion per beam analysis, the correlation were very low. So that means that in some cases it worked, the 3 steps before the people, the agent reevaluate the route, but in some cases it doesn't. And then I was analyzing how those agents performs in an individual level. Because most of the space syntax analysis analyze how the people perform in an aggregate level, but what happened with the individual level, how this individual can inform the aggregate level. So in this case, I found that those agents were performing a very random navigation through the space that doesn't represent the real movement in the right. So then I was analyzing how the people move in the space. It's not something that we can say, well, people walk 3 steps and then reevaluate the route. But this has something which is related with the length of each segment and the corresponding segment choice value. So we create that equation which represents how the people move relation with the length and the choice value of each segment, and that divided by 0.7, which is the overall dimension of each step, and the number of segments of the system. So doing that analysis, I obtained that in that building, according to the properties of the dimension and the spatial properties of that space, the number of steps is 6. And when I ran the analysis using 6 steps, I found those correlation of 0.66 with the real movement and 0.82 with the through vision. And also at an individual level, the movement of those agents were very similar than the human movement. And that is the overall picture that I obtained using that equation. And finally, I was trying to understand not only how the people move, but what the people remember from the space. So I asked the participants to draw a sketch of what they remember of the space where they were. I asked them to draw a plan diagram of what they remember, and those are some of the sketches that I obtained. Some of them are very interesting. Some of them are very accurate, as those on the right, but some of them present some strange results. So then I was analyzing how was the movement of those people, and some of them, even though they walk through almost all the spaces, they draw just a strange figure, whereas some of them didn't walk through the whole building, but the understanding of the overall space was really accurate. So then I was correlating how those drawings are reflected in the spatial configuration of those spaces. So I did those analyses where I divided the space in 11 areas. Each area, I give a score according to the number of times the participant draw each of those areas. And then I correlate with the integration of those spaces. And interestingly, again, I found some high correlation of 0.6 R squared between those areas that the people remember more times, and the properties of those spaces. So I'm in time. So finally, between the conclusion, the three-dimensional properties of the space doesn't significantly affect the navigation, but is the spatial configuration. It is confirming the theory of space syntax through that virtual analysis and human analysis and agent analysis. Highly integrated spaces are easier to remember and also easier to navigate. The number of steps before to evaluate the route taken depends on the metric relation between the length of segment of the system and its segment choice value. People tend to pause in locations which show higher isobit areas, perimeters, and minimal radial properties. Also, these pauses have a relation to important levels of PTA visual controls, and finally, the spatial configuration generate the most important effect in patterns of navigation of people. Thank you very much.
So again, we have time for a couple of questions.
Thanks very much for a very well presented paper. Have you pondered the possibility of actually connecting the results of your research with a real situation where color lines of, for example, the ceiling might induce movement and so on?
Yeah, well, it was an important point, but it was a little bit out of my research. I mean, I understand the influence of other people in the wayfinding tasks, but this study was focused just in the spatial properties of the space. I understand the influence of those generators or attractors that I told. Well, in this study I didn't include them because it will be. I understand the influence of those elements. I think it's a further study. Probably I can continue developing and analyzing those factors. Yeah.
Alan.
It's very interesting. I thought the one where you had the ceiling undulating was particularly interesting in your video clip. And I just wonder whether you would have found a better relationship if you had correlated the vertical dimension with aspects of the horizontal. As I understand it, the vertical dimension was just random and uncorrelated. Mm-hmm. And I just wonder if the ceiling informs you about the structure of the horizontal space, whether you might get a different result.
Yeah, well, I didn't include that correlation between the vertical and the horizontal. In fact, it was just a random ceiling. I think it could have some relation, mainly in what the people remember of the space. In fact, those spaces which were more accurate, represented by people, have some relation with those areas which present more three-dimensional differentiations.
Okay.
Right.
Let's have another round of applause and for all of the presenters in this session. Thank you.